Now, our final topic is implementing the string methods manually. Imagine you do not have any string methods. So what are string methods again? Upper, lower, title, swap case, all those things, right? Upper, lower, title, swap case. I have shown you in the previous video, right? Go, please watch it if you haven't. So let's say we don't have any of them. Let's say we don't have upper. Let's say we don't have any lower. Let's say we don't have any swap case. We have any title. We don't have anything. How can we implement it manually without any methods? For that, we need to understand some of the concepts which are very crucial, and I will use the Ascii table for that. You need to understand Ascii for that, right? So let's understand Ascii in depth. So in one of my videos, actually two of my videos, the first was basic data types and variables, and in the next video, the strings introduction video, I have told you what a string is. So string is a collection of characters. So what are characters? Characters are whatever you can see on a keyboard. It can be uppercase, it can be lowercase alphabet, or it can be numbers, or it can be symbols. Okay, these are the characters, and each one of them is called a character. When you combine all of them, or you make a combination of them, it becomes a string. So string is basically nothing but combination of characters. So if I say A or B or C, they are characters. But if I say A, B, C, D, E, F, and cat, bat, mat, sad, and they are just strings, right? So now, computers do not understand English, right? You know that. I have told you in the first video, in the second video. It was the title was Understanding Programming and Computer. So in that video I told you that computers can never understand English, or be it any human language, be it Hindi, be it Japanese, be it whatever. Computers cannot understand such languages. Computers can understand only 0 and 1. 0 is for off, 1 is for on. Basic electricity. I just this is in on position, and now this is 1. Okay, this is 1, and when I turn it off, it becomes 0. So you want to see 0, 1, 0, 1. So a computer understands only two things: off and on. That means 0 and 1, right? Now, when I talk about a character, be it uppercase A or be it lowercase a, be it uppercase Z or whatever, anything, be it numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, or be it any symbols, be it that at symbol in the email, or the hash symbol, or the dollar symbol, or the rupee symbol, whatever, each one of them, a computer cannot understand them. But there is a special way to represent them inside a computer. So I can say that let's say there are 7 binary digits. What are binary digits? Sequence of 0 and 1. Okay, so if I say 0000001 is the uppercase A, just like that I can say 0011001 is uppercase B. Like that I can represent all of these characters through the computer's language, which is 0 and 1. Now, long before, computer scientists and engineers invented a system of representing the human languages, and I specifically mean English languages, through ASCII. ASCII stands for American Standard Code for Information Interchange, and you can look it up on the internet, and I will show you also. So basically, ASCII is the way of representing all the printable and non-printable characters. I repeat once again, ASCII is the way to represent all the printable and non-printable characters on your computer in the terms of zeros and ones. Okay, so they made a table that, hey, uppercase A is 00001, uppercase B is 0111001, something like that, and then okay, 1 is 00101 or something like that. Okay, so I have the table in here. Let me show you. I have my Firefox opened. Yeah, so this is the Ascii tables. But before going to the Ascii table, let's read it. Okay, so what is Ascii table? ASCII stands for American Standard Code for Information Interchange. Now, computers can only understand numbers. Just as I told you, computers can only understand 0 and 1. So an ASCII code is the numerical representation of a character, such as lowercase a or @ symbol, that email symbol, or an action of some sort. Okay, and that's all for the introduction. So you can see that ASCII is the numerical representation, basically in terms of zeros and ones, that of English letters. So, for example, I want to know what is the numerical representation of the uppercase A, and the uppercase A is this one right here. Okay, you can see, right? Yeah. So this is the uppercase A, and how can we represent it? We can represent it using 65. Why 65? Because you can convert it into zeros and ones. So A is 65, B is 66. Let me show you in more detail. This information is not enough for you to understand. Let me just connect to my internet. Just go in here and search Ascii table. Search it. Then you get it here. Let's open an image. Okay, let's open it. Okay, not this one. We already have seen this. Something else maybe. Is there anything else that I can show you? So yeah, this is one of the example. You can see that the uppercase B is 10000010. So when you convert this thing, this 01000001 into the decimal form, that is the numbers we human understand, it will be 66. Okay, because the uppercase A starts from 65, so the uppercase B will be obviously 66. I cannot find that thing. Okay, it is not available. No, let me search. Nope, not here. Yep. Got it. Now as you can see, just look into this. Okay, should I make this a little big for you, or let's open it in full size. Open a new tab, and yeah, here you go. So as you can see clearly, let me find the uppercase A. Yeah, so this is uppercase A. Now uppercase A is written 01000001, and when we convert this thing into the number, the human understandable number, which is also called the decimal number, we get 65. Okay, see, we get 65, decimal 65. Similarly, if you convert B, which is 01000010 for the computer, I'm basically saying off, on, off, 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 on, off. So I'm saying that write B. Okay, I'm talking about the uppercase B, and the computer understands through this thing. Okay, computer does not understand 65 or 66. That is only for us to remember the thing. Okay, that is only for us to remember the position. But computers understand through these binary numbers. These are binary numbers, the combination of 0 and 1s. You can see. So A is off, on, off, 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 on. and B is off on, off off, off off, on off. C is off on, off off, off off, on. D is 0 1 0 0 0 1 0 0. Okay, so computers understand through these, but we as humans, we convert these things into decimal notations or decimal numbers, and we get 65. Well, yeah, we get 65, we get 66, 67, 68, all the way up to Z. Okay, we get till 90, and after Z there are some of the other characters. You can see, most of the characters you see here are present on your keyboard, and each one of them has a numerical representation in terms of binary, and then the binary is converted back into decimal. That's why we get 65 and 66. But the computers do not understand 65, 66. The computers understand in binary, and so the computers understand 0 1 0 0 1 0 1 0, something like that. Okay, but this is for us to remember, and these are very useful. Remember that. And yeah, so when we talk about numbers, so the numbers start from 48. 0 is from the number 48. Then you go to 1 2 3 4 5 6 7 8 9. This is the last number, and it is 57. Okay, this is the position in ASCII table. Remember this, this row, this column you have to remember properly in order to work with ASCII. And then you get colon, then you get semicolon, then you get the less than symbol, then you get equal to symbol, then the greater than symbol, then question mark symbol, and each one of them has a position. It is 63 for question mark. Then you get the @ symbol in email, @ symbol, and the position is 64. After this you get A, all the uppercase letters, uppercase A, uppercase B, uppercase C, all the way up to uppercase Z. And after Z, the position is 90, right? And right, the number of total alphabets in English language is 26. So these are the 26 alphabets. After that you get square bracket, the opening square bracket, then you get backslash, then you get again the closing bracket, then you get caret symbol, then you get underscore symbol, then you get backtick symbol, then you get all the small letters or lowercase letters from A to Z, and each one of them has a position. And then you get curly braces, open and close, then you get this pipe symbol, and this symbol over here, this is called tilde. Okay, if you have never seen this is called tilde symbol. But you may ask, what are these things? This null, stx, etx, all of these things, what is these things? Okay, so actually ASCII, let me go to the description once again. Okay, so you can see this. Computers can only understand numbers, so an ASCII code is the numerical representation of a character such as A or @ or an action of some sort. Now by this we mean that you guys ever noticed that we use \n in Python to print things? For example, if I say print and we say \n, what do we get? We get nothing. We get nothing. We get this big space. We don't get anything. Why so? Because this character is non-printable. So we need to distinguish between which characters are printable and which characters are not printable. So all of the things you see on your keyboard are actually printable. Let's say A, B, C, D, E, F, G, H, I, J, K, L, uppercase, be it lowercase, or be it digits, or be it symbols. All of them can be printed, but there are things which cannot be printed. For example, you can see this backspace. Okay, the backspace on your keyboard, it cannot be printed, right? How can you print a backspace? You can't. Then you get horizontal tab. You have the tab button next to Q button. Okay, so you cannot print the tab button also. So there are things which you cannot print, and they are called non-printable characters. And again, there are things which are printable, and they are called printable characters. So ASCII table contains all the printable and non-printable characters in terms of numerical representation. And each one of them has a position, 65, 66, 67, like this, from 0 to total of 255. Okay, So it has these many numbers in it. So these are the positions, but each one of them has to be converted into 0 and 1s for the computer to understand that what we are actually saying. Okay, so each of the positions, be it 65 or be it 67, has to be converted into the binary form, that is 0100, this form, okay, this form, in order to in order to the computer to understand this. Now let's talk about some of the important things that you will need. Okay, few. Let's have a screenshot here, because I want to show this. So yeah, I just want from from this portion up to this portion. Yeah, up to this portion, that's what I want. Open an image editor. Now notice very carefully what I do. Okay, let's now let's take a pen. Is that a pen? Yep, that is a pen. Line thickness is 7, 10, 12. Okay, that's going to work. Now so what is the position for A, the uppercase A? I mean this one. Oops, it is too much. Line thickness. Yep. Okay, I guess that will do it. So I'm talking about this A over here, and let's make it blue because all the things are in red. So let's make it blue, and that would be better. Apply. Yep. So I'm talking about this number. So the position is 65, right? So now if I want to convert this capital A to small a, now notice the position of small a, it is 97. Now notice the position of the capital A, it is 65. Now what is the difference? What is the difference? Let's use Python. So the lowercase a is 97 and the uppercase a is 65, and so the difference is 32, right? So the difference is 32. Now if we want to go from here to here, right, we need to add 32, right? So if we want to go from uppercase A to lowercase a, we need to add 32 with 65 to get 97, right? Again, the same thing follows for B as well. So the position of B is 66, the uppercase B I'm talking about, it is 66, and the lowercase b is 98. So what is the difference between 98 and 66? Let's do it. 98, 66. Again we get 32. Again we get 32. The same thing applies for the uppercase C as well. The position of uppercase C is 67. You can see this. The position of uppercase C is 67 and the position of lowercase c is 99. So what is the difference between both of them? So 99 minus 67. Again 32. So basically we can say that the difference between lowercase and uppercase is 32, right? We can conclude that because this will apply for all the uppercase and lowercase letters. So to go from uppercase to lowercase, we need to add 32 to the uppercase letters, and in order to go from lowercase to uppercase, we need to subtract 32 from lowercase, right? So we can clearly see that the value for, or the position of small d or lowercase d is 100, right? So let's write 100. Okay, and then let's say we just subtracted 32. We just subtract this number, the difference between the lowercase and uppercase. We subtract the difference from the lowercase position and we get 68. Now let's check what is the position, which is the letter that is represented by position 68. So let's check for 68, 64, 65, 67, 68, 67, 68. So again we get D. You can see 68 stands for the capital D. Okay, now let's take any random number. Let's take M. So now let's say I want to go from uppercase M to lowercase m. So what I would do is I would take the position of uppercase M, which is 77 right here. I will take this one 77 and I will add 32. We get 109. So let's check which is the 109th position. So 1 2 3 4 5 6 7 8 9. Wow, we get 109 position and it is the small m. So we have the basic principle in here. If you want to go from uppercase to lowercase, add add 32 to the uppercase position. Okay, and if you want to go from lowercase to uppercase, subtract 32 from the lowercase position. Okay, now let's see this in action. So I told you that every character on your keyboard has a particular position. So if I say and there is a way to look at that characters, and that function is odd. Okay, that function is called odd. Let's give a character inside this. Let's say I want to know the position of uppercase A. Give me the position of uppercase A. I hit enter and I get 65. I get 65, right? And there is the opposite one. So if I want to check which letter is in the 65th position in the Ascii table, I can say char and I give 65. Boom, I get A. So using odd function we can get the position of the given letter, and using the char function we can get the letter of the given position. So here we give the position to know the letter, and here we give the letter to know the position. That's the only difference. Now if I want to convert, or I want to change uppercase A to lowercase a, what I would do? So the rule is I want to add 32 to the uppercase position. So what I want to do is odd. I want to say A, and this will give me 65 because you can see the result is 65, and I want to add 32. So that gives us 97, right? That gives us 97. And when I say char give us the 97th character in Ascii table, boom, it gives us A, small case A. How nice is that? Now we can do this in a single line. We can say that char, and inside char we say odd. Inside odd we give, let's say, well, okay, let's give any character. Let's say I want Z. Okay, and I add 32 to it. What do we get? Boom, we get lowercase z. Again, what is the rule for going from lowercase to uppercase? Subtract 32 from the lowercase position. So let's check the position of z. Okay, so to check the position I give odd, and we check the position of z, lowercase z, and it is, well, 122. Now we can say char. That means inside char we pass the position. We pass the position to get the result, or get the character in that position. So if I say char 65, it gives me the character which is present in the 65th position of Ascii table, right? So if I say char, and inside char I say odd, which will give me the position of a given character, and the position is, you say, well, I want to convert z. I want to know the position of z. That's why I give odd z. So this will give me the position of z, which will be 122, and then I subtract 32 from it. Okay, and this, this whole thing, will give me a number, right? And whatever the number is, I want to know what is present in that position using the char function. So let's see what happens. Boom, we get uppercase Z. So that's how it works. The difference between lowercase and uppercase characters in ASCII table is 32. And with this foundation, we are now ready to build our own string class methods, which is upper, lower, swap case, title, all those stuffs. Okay, great stuff's coming ahead. So let's get started. Let's open another terminal. We will start fresh. Now let me open the MS Paint here. Now let's say we have a word. Okay, let's have a word. I will show you the algorithm. I will show you how to convert it. You know the steps. You know how to convert it, right? But I will tell you the whole process of converting it. And that is really important, so be very careful. So let's say I want to write that, let's have a word, let's say computer. Okay, so I said computer, and I want to convert all of each of these alphabets to uppercase. So I want computer. So I want computer. So this is what I want. Now what I would do is, this is a string, right? So string is an object. Now I will use a for loop. Okay, so I will use a for loop to iterate through all the elements of this letter. Okay, so I will iterate through each of them using a for loop. I'm sorry for my handwriting. Yeah, so I will use a for loop and I will iterate through each of these elements, and I will check if okay, let's write it. I will check if let's say x, this thing I represent it using x, for x in string. So this is the reason I write x. So for every element, or you can say for every alphabet, for every alphabet. Okay, so if every alphabet, or you can say just alphabet, that would be nice. If alphabet, and just add odd, this will give the position. If odd alphabet more than or equal to 65, I'm sorry, not 65, well, more than or equal to 97, and odd alphabet less than or equal to 122. Okay, now what I will do is alphabet equals to alphabet equal odd alphabet. I have to make this a little bit longer. Yep, alphabet plus 32. I'm sorry, minus 32 actually. 32, because we are going from lowercase to uppercase, and this is the reason we need to subtract 32 from the position of the lowercase, and then we enclose this in a bracket and we call the char function. Okay, that's what you get. And then, okay, this is the process, this is the whole process of it. Now we need to do something extra. Let's first move this to a better place. Yep, so I just move it to a little bit lower, and then I say, we will have a list, let's say alphabets. Okay, so this is an empty list, right? In this empty list, for every character we will append all the letters. So this is the loop, this is the for loop, and for for every element we will check this thing, and I will explain, just hold on. So now let's first see what we are doing. So we are saying for every element in this string computer, if odd alphabet, so what is the first element here? C. So this will be replaced by C. So if odd C more than equal to 97 and odd alphabet, that means again C in here, less than equals to 122, that means we are giving the range. So let's check it out once again. What is odd C? Boom, 99. So if I check that, if okay, well, odd C more than equal to 97 and odd C less than equals to 122, boom, we get true. Why true? Because we are saying that check the position of C, and if it is check the position of whatever you pass in here, and if it is more than 97 and less than 122 or equal to, then we can conclude that that alphabet is in lowercase, right? So whatever we put here, because let's say we need, let's say we need char 97, so it is A, and again char 122, it is Z. So whatever comes between these things will be lowercase, of course, because after lowercase a you cannot expect an uppercase b, you will always expect lowercase b only. So whatever comes between these will be considered as lowercase, and that's what we are saying. We are checking the position of the given letter or alphabet, and if it is more than or equal to 97, why 97? Because the 97th position of ASCII table is the small a or lowercase a, and again we check if it is smaller than 122 or equal to 122. Why 122? Because the 122nd character of ASCII table is small z or lowercase z. So whatever comes between these things, between these two ranges, this is the lower range and this is the upper range, and whatever comes between these or are equal to these, we can conclude it is a lowercase letter, right? As simple as that. Boom. Now once we check that if it is lowercase, if this is true, that means it is lowercase. Okay, it is lowercase. Okay, if this condition is true, right, this if statement in here, then we can say that it is true. Now once it is true, what we are doing is we are saying alphabet equal to that means we are changing the alphabet with odd alphabet minus 32. So we are first getting the position of alphabet. Okay, so we're first getting the position of alphabet, then we are subtracting 32 from it. When do we subtract? Let's see the rule once again. When do we subtract? We subtract when we want to go from lowercase to uppercase, right? And this is the time we subtract 32 from the lowercase position. This is the lowercase position, this odd alphabet is the lowercase position, and then we are subtracting 32 from it. That's how we get the uppercase position. And once we get the uppercase position, I pass this to a function called char, and char gives us which is the element in that position, okay, or which is the character in that position of ASCII table. And that's how we get the uppercase letter, right? So let's say, for example, we have let's say we have 97 here. Okay, so the alphabet is A. Let's take A. Okay, so A is the alphabet. So we check this condition: odd alphabet more than equal to 97 and odd alphabet less than equals to 122. So it satisfies the condition because the odd A will give us 97, right? It will give us 97, and 97 is equal to this condition, right? It is equal to this condition as well as this condition. Why? Because 97 is always less than 122 and 97 is always equal to 97. So this condition is true. And then we say alphabet equals to, we say char odd alphabet, and again odd alphabet will give us 97, right? 97, and then we subtract 32. We subtract 32, right? And we get 65 for that. And we say, or we say char 65. Once we say char 65, we get A. Okay, we get the uppercase A. So that means we have converted L case to U case. That means uppercase. Okay, we have successfully converted the lowercase to uppercase. And that's what we will do for each and every element of the given string. That is for every element of the given string. Okay, we will do the same thing. And again we have an empty list here. Okay, and once we convert each one of them, we will put it, or we will append it to this list. We will append it to the list, right? So let me, so after, inside for loop, this is again inside for loop. This is not outside of the loop, because for every element you want to do this thing. For every element you want to do this thing, and if this condition is satisfied, well, good, you just convert it. And if it is not, you don't need to convert it, just skip ahead. And once you skip ahead, the next thing you need to do is you have to say alphabets dot append, and you say alphabet. So you basically put the alphabet, either converted or non-converted. So alphabet will be converted into uppercase if it is lowercase, and if it is already uppercase, then this condition will hold false. I'm talking about this condition. This condition will hold false if any one of them, if one of them is uppercase. Okay, so this will only apply for lowercase, not for uppercase. So if a character is already uppercase, why do we need to change it? It is already in uppercase. So just keep it that way, and we put it into the list. And once we put it into the list, we can directly say that well, we say that join alphabets. So whatever is in the list, we just join them together to get the answer. So that is our basic ideology, and the same thing will hold true for for lowercase as well. So let me implement it once again. Well, is there a way to remove all these? Yep, nice. Anything else? Nope. Okay, not a big deal. So now let's remove this. I have to remove this. Okay. Let's do this. I have just to remove this one only. Remove this thing. Remove this thing only. And remove this part. Okay, not this part actually. Only this part. Perfect. Perfect. Now, we will do this. But what if I want to go this way? I want to convert uppercase into lowercase. So now this is our current word. This is not the current word. So let's just cut it out. This is our current word. Okay. And we need to convert it into this form. Okay. So let's just bring it in here. If you select, just take it. Yep, I just take it, and well, I take it here, and this one, you over here. Perfect. Yeah, nice. So that does our job. Now we will convert uppercase to lowercase. And how can you do that? It's really easy, just do a few changes. Say that 65 in here and put 90 in here, and just remove this one, this negative sign, and boom, 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 boom. We just add a plus sign in here, and boom, you're done. Boom, finished. Why so? Because let's take an example. Let's say you take an example A. Okay, so you have an alphabet A which you have to convert into A, small case A. So what you do, you have A in here, you check if odd alphabet, in this case it is A. So what is odd A? It will be 65, obviously, because odd A will be 65. You can check it out. You can check it out on the Python interpreter. I can show you, right? You have already seen, but let me show you once again. I say odd and I say A, boom, I get 65. So now I can say that well, this condition is true because odd A is 65, and thus 65 is equal to 65, as well as 65 is less than 90. So this condition is true. That means it is uppercase. Okay, not lowercase. It is uppercase. So if it is uppercase, we say that alphabet equals to CHR, odd alphabet. This again gives us 65, and then we add 32. Once we add 32, we get 97, right? And char 97 will give us small a. Okay, so thus we get lowercase, and we get to here. Okay, now I will implement it in Python. So now you have understood. Now let's write a function of our own. So our function is my uppercase, or just write it uppercase, and you take a string as a parameter, and you say that there is a list, and that list is the alphabet. You can call it whatever you like, but I just call it alphabets. I just keep it that way. And then you say for letter in a string, if you give a bracket, let's just put some space in here, and you say odd letter more than or equal to 97, and odd letter less than or equal to 122. So that means this is the lowercase letter, and thus we have to convert it. So we will say letter equals to CHR odd, and we get letter, and we subtract 32. Boom, 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 and we're done. And then we say alphabets dot append letter, and finally we return this thing, or join alphabets. Now let's see if this works correctly or not. So we say uppercase, let me just write it, uppercase, and we provide a lowercase letter, word. So let's give hello, and let's see if this works or not. Enter. See, it works. I had passed all the small case letters, and it converted all of them into uppercase. So let's check out some other examples. Let's say uppercase, and I give um, let's give hello, like that. Boom. Right. Now let's give a sentence. Let's give a sentence. Uppercase. Let's give the tagline of Py-Volution. Your road from human to Pyman. Boom. And all of it gets converted into uppercase. You know. So this logic is applied. So let's say this is the sentence you passed, right? So this is the sentence you passed. So this goes in here. Okay. Then you have an empty list, and then you start a for loop where you say for every letter in the string, that is for every letter in the given string, all of this. Uh, so you have all these letters in the string, and so we start a loop. Okay, and in the loop we say that if the position if the position of the given character is more than 97 and less than 122, okay, that means we can conclude that it is in lowercase, and that's when we say letter equals to, we say find out the position of the letter and just subtract 32 from it, and then whatever the position is, give me the character based on the position, and that's how we get the uppercase character. And then what we say is alphabets.append letter. So we put the letter, put every letter irrespective of lowercase or uppercase. Every single time this loop starts, we put the letter into this list, and once this is finished, we return this thing, which means whatever there is inside alphabets list, just join them together and pass them. Okay, that's what I mean. So again, this will happen even if this is false. This is, if this is false, this will happen, and again if this is true, this will also happen, because this is not inside if. Okay, don't get confused. This part is inside if, this part is not inside if. Okay, so only if and only if the letter is a small case letter, then it will be converted into uppercase, and after that it will be put into the list. Okay, and that's how we get our uppercase. So we made it. Now let's make the lowercase one. So I say lowercase. Let's make another function def lowercase string, and you say alphabets, right? You say for, you just say the same, just say the same thing for letter in str. If now here you make changes, if the position of the letter is more than equal to 65 and the position of the given letter is less than or equal to 90, then we can conclude that it is uppercase, and we have to convert it into lowercase. And how can we convert it into lowercase? We just have to add 32 to the current position. So we would say letter equals to char odd letter plus 32, and we have it there. And now we will put the letter into alphabets. I'm sorry, let's put a S here. So letter, and again just return this thing, return dot join alphabets, and we are done. Now let's see if this works or not. So I say lowercase, let's give something hello. Boom, everything converted into lowercase. Let's take another example. This time let's give it, hello. Again this H was in uppercase, it has been converted into lowercase. Now let's give this a string. So let's copy this. Let's copy this thing. Just copied it, and then I say lowercase, and I paste this. Boom, all of it converted back into lowercase. Okay, this was uppercase, and each and every letter has been converted into lowercase, and then it has, then you got the result because it returned all the alphabets after joining them. So you have it. Now you can do the swap case. Let's make a function for swap case. So def swap case. You know what is swap case? Let me give you a demo, uh, or a reminder actually. So let's have something called, okay, so this is in, this is in uppercase, this is in lowercase, this is in uppercase, again this lowercase, again uppercase. So alternatively you give upper lower, all those stuffs. Okay, so this is called swap case. Now if I say that, let me give you an example. Hello dot swap case. It was swap case or what? I guess, yeah, swap case. Yeah, okay. So this is swap case because it will just give you the complement. So if this is small, make it big. Again, this is small, make it big. So let me give you another example. That would be better. So if you say uppercase H, lowercase e, uppercase L, lowercase l, uppercase O. Now you say swap case. Boom. So you have it. Uppercase H has been converted into lowercase h. Lowercase e has been converted into uppercase e. Uppercase L has been converted into lowercase l. Lowercase l has been converted into uppercase L, and uppercase O has been converted into lowercase o. So this is the reason it is called swap case. If it is uppercase, it will give you lowercase, and vice versa, right? Now let's build it on our own without using the swap case. So let's say we have something called swap case, and again str. Now you all you have to do is put both the things. Okay, so you just say alphabets, and there is this brackets for letter, and this time you will check both. You will check if the letter is small, you will also check if the letter is upper. Okay, so you'll check for the both. I mean, you will do this as well as that. Let me go to the top. Yep. And also you will do this also. So you will do both of them. You will check if the letter is small case or lowercase. You will also check if the letter is uppercase or not. So that's how you can get swap case. So let's implement it. So yeah, I was here for letter in string. If, okay, just paste it because I want to show you the power. So basically you just copy this thing over here and Control C Control V, then you go in here again, just put it, just copy it, paste it, right? So I say lowercase to uppercase. Okay, this is just a comment, okay, so that you can understand what I am doing. Now again do the same thing, just paste it again. This was for checking lowercase, and this one is for checking uppercase. So in case of uppercase, just make this 90 and make this 65, right? Then copy this, paste this, and just remove this one. Just remove subtraction and do addition, because for going to uppercase, for going to lowercase from uppercase, you need to add it. So you are going from uppercase to lowercase. Okay, and when there is a difference of 32. There is a difference between 32. If you are having uppercase, you need to add 32 to go to lowercase, and if you are having lowercase, then you have to subtract 32 to go to uppercase. That is the rule. And after all of that, you do what you do. You just do this thing, alphabets.append later. Okay, just do this thing and it will work. Control C, Control V. There should be indentation or what? Yes, yeah, that's it. Finally, return join alphabets, and you have it. Boom. Now let's check if this works or not. So I say swap case, and I give something called hello as like this, uppercase H, lowercase e, uppercase L, lowercase l, uppercase O. This is not working properly. Let's see the reason here. So uppercase H, something is wrong. Something is terribly wrong. Okay, I need to do this thing. I just need to do this thing. Let's copy it out. Let's see if this solves the problem or not. Perfect. And do this elif. Okay. Then you say plus 32. Perfect. I guess that will do it. Let's finally return it. This thing. Let's see if this works or not. Swap case. Now let's call the upper one. Boom! It works perfectly. Now this time it works perfectly because last time I had given if only, so both of them were getting checked. Okay, so put an elif here. Remember, you either satisfy this condition or you satisfy this condition, right? So remember to put an elif here, otherwise it won't work. So now we have our swap case. Now we can implement swap case with some other examples also. Now let's say I give small, capital, capital, capital. Okay, boom. So the small case letters or the lowercase letters has been converted into uppercase, and the remaining ones has been converted into lowercase because these were already uppercase, so it has been converted into lowercase. Boom. Now let's implement another title. So title, right? So let's say my name is Subhodeep dot title. So you can see when I give the title method, what title method does is it just changes, it just it just converts the first letter of every word into uppercase, right? So every letter of the word of every word has been converted into uppercase. So how can we implement this? Let's see this. So this is a string, right? Well, let me open Microsoft Paint for this reason. I need to show you Microsoft Paint, simply Paint. Yeah, you have it. Now let's take an example. Let's say our example is hello world. This is one of the simplest examples. So let's start with that. So yeah, our example is hello hello world. Okay, not this, because this is already in title. Hello world. Okay, so this is our original string, right? And if we say that when we use the method title, let's say we have the same string here, so I say hello world dot title, right? When I say this, it gives me this thing. Okay, it gives me, let me make this a little bit longer. Yeah, and then it gives me this thing, hello world, right? So notice what's happening. Just let me take the brush once again. So notice what's happening. For every word, this is the word, these are the two words we have. For every word, what it does is it changes the first alphabet of every word to uppercase. Okay, and all the remaining letters are changed to lowercase, right? So that is what's happening. So here it is lowercase, it has been converted into uppercase, and again it is in lowercase, it has been converted into uppercase as well. And all of the rest of the elements, or all of the rest of the alphabets are turned into lowercase, as you can see, all these into lowercase, right? All of them. So let's understand the logic behind this. Yeah, let's keep this. So what is the logic here? The logic here is, we will first check if the first element, or the first alphabet of every word is in uppercase or lowercase, right? If uppercase, if lowercase, convert it into uppercase, right? So let's write the steps as well. Step 1, if the first alphabet of a word is lowercase, is in lowercase, is in lowercase, then convert it to uppercase, right? This is the first thing you have to do. And what is step 2? Let's write the step 2 as well. Step 2 is, if check if any of the remaining alphabets are in uppercase, and if it is the case, convert it to lowercase. Okay, so these are the two things you have to do. So the first step, if the first alphabet of a word is in lowercase, then convert it to uppercase. That means if the first letter of a word, let's say H, is in lowercase, so this condition is right, then convert it into uppercase. So we have to make this H. Okay. What is step 2? Check if any of the remaining alphabets are in uppercase, and if it is the case, just convert it to lowercase. So let's check if the remaining elements are in uppercase or not. So yep, so the next element is E. So E is in uppercase, right? We have to convert it into lowercase. And next element is L. It is already in lowercase, so no need to convert it into lowercase once again. So it is already in lowercase. Again, L is again in lowercase, so no need to convert it. But again, O is in uppercase. Convert it back into small case. I mean lowercase. Okay. Similarly, for the next word world, the first alphabet is in lowercase, so simply convert it into uppercase. The next, so step 1 is done, right? Step 1 is done, and step 2 is check if any of the remaining alphabets are in uppercase, and if it is the case, convert it to lowercase. So let's check the next element, which is O. O is in uppercase, right? So just convert it to small case or lowercase. The next element R is already in lowercase, so no need to change it. It will be as it is. The next element L is again in lowercase, so no need to change it. However, the next element D is in uppercase, so change it to lowercase. And we get hello world. And that's how title works. That's how title works. Now we will do the same thing using manual methods. We will write our own title method from scratch. So what is the process? So the process of converting this thing into title is, let me explain. What you have to do is, yep. So this is your whole string, right? Let me take the brush again. So this is your whole string, right? This is what the user provides you. Now what you have to do, you have to break it into pieces. Now how many words are there? There are 2 words, right? So you will break it into 2 pieces, right? Okay, just remove this one, this underline. Yeah, perfect. Now you will break this into 2 pieces. And now we are done. We have now 2 words, right? Hello and world. And how did we do this? We simply said, whatever the string is, string or string dot split. Okay. So what is string? String, just a variable. Okay. Inside string variable, this string is contained. So hello world is present inside string, and we say string dot split, and that gives us a list. What is that list? The list is hello world. So we get this, okay, right? So this is what we get once we break it into pieces. Now the next thing is to break every word into multiple pieces. But now we cannot use this thing, okay? Now we cannot use this thing because split only works when there is at least a space or hyphen or some other character, right? You know this. If you don't, please watch my previous video. And for a reminder, just let me show you once again. What do I mean? So if I have hello world and I say split, it gives me 2 different parts. But when I have, let's say, only hello and I say split, see, it can't do anything. Why? Because there must be at least a space between 2 strings. But if there are no strings, nothing is separated, everything is in together, this won't work. Okay, if a string is together, let's say I write hello world and I say split, see, it won't do anything. So there must be a separation using space or hyphen or slash or whatever the value is. Okay, there must be something between them, and if it is not, then this method won't work. So how can we divide something individually when it is together? So we will use this method list, and we will say hello. Boom. Now we get the individual elements, right? Now we get the individual elements, and now we have the first element, which we will convert into uppercase, and we will check for the remaining elements. If they are in uppercase, we will convert it into lowercase, right? So that's the logic here. So we can use split when there is a separation, and when there is no separation, we will use list. Okay, that's the logic here. So we have our demo string here. String. We have our demo string, which is hello world. Okay, so this is our demo string. After this, we have a list called original words. Let me just make this a little bit bigger. And yep, okay. So we have well, a list called original words, which has string dot split. Okay, this thing. So basically means we have this one. Okay, we have this list. Okay, now we have another list called new words, and it is basically a empty list. Okay, it is empty list. Okay, so till now what I mean is, just let me take the brush here. Till now, this is the string that user provided us, right? And then we basically cut the string into multiple pieces. So by multiple pieces, I mean multiple words of the string. So how many words are there in the string? Only 2 words, and we make a list out of it using string.split split method. So if you haven't seen this earlier, please check out my last video to learn about this more. So split method does, it basically says what it does. It splits the string. That means it breaks the string into multiple parts. So boom, 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 boom. So we have 2 parts here, hello and world, right? And we have a list here, right? And then we have a new, another list, another empty list called new words. So what this list does is, the new words which will be formed. That means, this thing, it will contain hello and it will contain world, right? But it is still not here. Okay, so it is still not here. New words will contain all the new words that will be formed after manipulating this thing. Now, what's the next thing we will do? We will start a for loop, and we'll say for words, okay, for word in original words, for word in original words, right? And we say for word in original words, we make another list called original alphabets, and we have list word. Okay, so we have this, right? So by this, what I mean is, let me explain this one. Let me take the brush. So I say I used a for loop that iterates through every word or every element through this list. So what are the elements here? Hello and world. So there are only 2 elements, and it will, a loop will iterate through each one of them. And for every element, that is for every word inside this list, we say that original alphabets equals to list word. What does this mean? This means that we take every element, that is every word, and break it into multiple pieces. And by pieces, I mean alphabets. So we get here this thing. We get a list of alphabets. So we get H, uppercase E, lowercase l, again lowercase l, and finally uppercase O, right? So this is what we get for every word, for this word, for hello, we get this thing inside this original alphabets list. Once we do this one, list word, so it will break each one of the alphabets like this, dot, 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 dot. It will break each one of them, okay? You can see clearly that it breaks each one of them into parts and it makes a list out of them. And this list contains each and every alphabet of the given word, right? Let me just remove these things. Perfect. Yeah. So now the next thing we will do is just change the font, because this font is not that good. So let's just change it. Not this one actually. Anything good? Maybe this one. Well, not this one. Maybe this one. Yeah, okay. This one is okay, right? Yeah, this one is perfectly fine. Now we will have another list called new alphabets. And this will be again an empty list. And why do we need this? We need this because, you know, we will take each one of them, and we will change it. We will change it from uppercase to lowercase or from lowercase to uppercase, and then we will put each one of them into this. After manipulating every element, we will put it into the new list. We will append it into this one, right? We will append it into this one, and if we, and we will do this for every element. We will do this for each and every alphabet, right? And then we will have the new word, and basically that means we will have something like this. Inside this thing we will have something like H E L L O, right? So I'm sorry, just change it. Yep. H E L L O. Perfect. So this is what we will get inside this thing, okay? So as you can see, once we change it, once we change this thing, the first element from lowercase to uppercase, we put this into this list. So that's why this one is the first element. Again, we change this from uppercase to lowercase, and then we put this. So this is the second element. And this is, we just keep it as it is because it is already in lowercase, so no need to change it this. And same goes for this one also, right? And again, here O is in uppercase, we change it to lowercase, and then we put into this. And that's when we have our new alphabets, right? New alphabets. And then what we will do is we will join all of them, right? We will join all of them, and when we join all of them, we get this thing, hello, right? We will get this thing, hello, and then we will append this thing. After joining the new alphabets, we will get this thing, and then we will append this thing into this thing, new words. And we will do this for every single word. So we have two words, hello and world. We will repeat the same steps for both of them, and after modification, and then after joining, we will put this into new words, and then we will join new words. Then we will join whatever it is inside this, and then we will get our original result. Okay, so that's how our process follows. But well, I will explain as I go. Just remove all of these, right? So we have our new alphabets. Then we say if um, let me write a code here. If odd original alphabets 0, that means the first element, because obviously the 0th index is the first element of any list, right? So odd original 0 more than or equal to 97, and you guessed it, because you have done the swap case and all those upper and lower things. So we will write the same thing once again. Original alphabets less than equals to 122 colon. So just make this a little bit bigger. And just put this in a bracket, because there are multiple cases, right? So this is the condition. Then we say original alphabets 0 equals to char. I am not explaining this part because you already know, right? Because I have explained it just few minutes ago when explaining swap case and upper and lower methods. So I'm just writing it as it is. So we say odd original alphabets 0 minus 32, right? We will do this thing, and then we will say outside of this if condition we will say new alphabets dot append original. Okay, done. And that's it. Now let me explain this part, what I am doing. So we will check if it is a lowercase character using this thing, right? And original alphabet 0. So I say that what is the 0th element of this list? So obviously it is H, right? For this word, what is the first element? It is this one, right? So I am referring to this one. Now we will check that if this word is, if the position of this word is more than or equal to 97 and less than or equal to 122, then we can conclude that it is a lowercase letter. We will just convert it into uppercase using this thing over here. We say original alphabet 0, that means obviously this one, and we just convert it into uppercase. You know the method, char odd, and we say original alphabet 0, that means H minus 32, and obviously we will get the uppercase letter. And then we append, or we can say we put the element, or the modified element into this one, into new alphabets. So what is our first element? Our first element is H, because we have modified it, right? So this is our first element, H. And you may ask that why am I putting this outside of this if statement? You may ask this. The reason is, it may be the case that H is already in uppercase, right? It may be like this. So in that case, we do not need to change it into uppercase, because it is already in uppercase. So we just ignore it. And whatever the case is, if and only if it is a lowercase letter, that means H, then only we convert it into H, and then we put it back into here. And if it is by default H, then no need to check this thing, right? No need to check this thing. Just directly put this into the list, right? So our first element is H, right? Now since we have the first element here, what we will have to do? So the first step is completed, right? So the first step was to check if the first alphabet of the word is in lowercase or not, and if it is the case, then convert it into uppercase. And we did that, right? And what is the step 2? We will check if the remaining of the alphabets are in uppercase or not, and if it is the case, we will convert it into lowercase. That is the thing. Now, since we have already used the the first letter or the first alphabet, we will start another loop from here. Okay, we will start another loop from here. And how can we do that? We will say, let me write it here, for alphabets in original alphabets, and we use slicing, you guys know this, and we say start from index 1 and go up to all the way to the end. So now I start a loop from the first index, that is from this one, from this part, because this is 0, right? And this is 1, right? 0, 1, 2, 3, and 4. These were the indexes. So if I say start a loop from all the elements from original alphabets, 1 colon. And 1 colon means 1 is the starting point. And what is 1? 1 is the second element of an array. So I refer to this element, E. And I didn't mention any end. So that means it will go up all the way up to the end. That means up to this thing, this O, right? Now we say inside this, for sorry, not for, if alphabet, I'm sorry, if odd alphabet, let me make this a little bit longer. We are perfect. If odd alphabet more than or equal to 65 and odd alphabet less than equals to 90, that means we in in other words, we want to check if the alphabet is in uppercase or if it is in uppercase, and if it is the case, we convert it back into lowercase. And how can you do that? We say alphabet equals to char odd alphabet minus, I'm sorry, plus 32, boom boom boom, done. And once we convert it, that's it. Now, yep, once the if condition is completed, we will say just new alphabets dot append alphabet, right? Okay, so what I am doing here is I am saying that for every alphabet inside original alphabet 1 colon, that means starting from the index 1, that is excluding the first element, go all the way up to end, and for every element inside that we check if an element is uppercase or not, right? And we know that if the element's ASCII position is more than or equal to 65 and less than or equal to 90, it is an uppercase letter. And if it is the case, then we convert it back into lowercase, and then we put it into the new alphabets. So what is the next element? It was this uppercase E, right? It was this thing, and this thing satisfies this. I'm sorry. This E satisfies this condition, right? Because it is in uppercase. That means we will do this. We will do this thing, and now it has become this. Once it has become this, we will put into this new alphabets dot append. That means new alphabets means this one, right over here. So what is our next element? Our next element is E. Okay. Now, what's the next element here? The next element is L. Now L is already in lowercase, so this condition is not satisfied. So no need to convert it into lowercase because it is already in lowercase. So just put L inside this. That means our next element goes in here all the way inside this new alphabets list. The next element is L. Again, what's the next element? The next element is again L. Again, L does not satisfy the condition, so no need to convert it into lowercase because it is already in lowercase. Just put it into this list. That means our next element goes in here, and our next element is L. And finally, the last element is O. Now, O satisfies this condition because O is in uppercase, right? That means it satisfies this condition, and that means we will convert O into small case o using this one, this alphabet, right? And then we will put the new O, that is the lowercase o, into the list. That means it goes all the way inside the new list. Sorry, that means it goes inside the new list, and our final element is O. Now we have our elements, right? Each one of them is a separate element, right? So we have our new list or new alphabet list, and it looks like something like this. We have a list here. It says H E L L O. So we have a list. Now what's the next step? The next step is to join this together, join all of them. And if we join all of them, what do we get? We get the whole word, which is hello. We get this, and once we get this, we put this hello inside the new words list. And how can we do that? We say that just remove all of these things, keep it here. Let me use the select tool. Is there an eraser tool? Yep, okay. And control plus plus plus. It doesn't work actually. Okay, well, yeah, fine. Just let me rub this up. Okay, perfect. And here too, this one, this is unnecessary. Yep. And how can we oh, oops. Yep, that's fine. Now how can we join this? We will join this using this one. And once we join this, using let me use the method here. We will say that dot join, and we will say new alphabets, right? That's what we are going to say. And after saying this, we will put this thing into the new words, right? And how can we do that? We will say new words dot append, and we will put this, right? Boom, and we are done. So we will write this thing. So just remove this one and let's write it here. Outside the loop, remember to write this outside the for loop, because inside the for loop you are changing the single alphabets of the remaining the single remaining alphabets of the word, right? So do not write this inside the loop. Once you complete all the process, that is once you finish the loop, only then you write this. You say new words dot append, right? You say new words dot append, and you start a bracket and you say dot join, and then you say new alphabets. Okay. So once you do this, um, once you say this thing, this hello, basically this is the thing in here, right? And then new words dot append, that means hello goes inside this list. So what is our first element? What is our first word? First modified word? Well, it is hello. Hello. So this is our of our list, right? Yeah. So this is our first element. Now again, uh, let me use a brush. Once we do that, so that means this part is completed, right? This loop is completed, and this statement is also completed. Now where do we go? We go to the outer loop. Remember, this is the outer loop, and this thing over here is the inner loop. Okay, so there are two loops. The outer one, that means this one, and the inner one, that means this one. Okay, so once we finish the inner loop, as well as the final statement of the outer loop, we go back to here, right? We go back to this for loop. Now the same process will follow for world as well, right? So for world we check if this is in small case or not. So yes, it is in small case. So that means we will use this thing to convert W to uppercase W, and then we will put W into our new alphabets list, right? We will put W into this new alphabet list. Then we will start a loop from the remaining elements of the word world. So there are four more alphabets, ORLD. Now for every alphabet we will check if the alphabet is um, uppercase or not. If it is uppercase, convert it into lowercase. That means for in this case, O is uppercase, so convert it into lowercase o, and then put this into new alphabets. So our new elements are like this. Let me write this. W O, because O has been converted into lowercase. Again the same process will follow, and since R, this thing, let me write this once again. So as you can see, this R and L as well are already in lowercase, so no need to check this thing. Okay, so this will not be true because it is already in lowercase, so no need to convert it into lowercase. Again, put both of them into the list. So we say here R L, And finally, you can see D is in uppercase, so we convert it into lowercase, and we have D, right? So we have this whole thing, and this is basically the new alphabets list. That means this one over here, new alphabets list. And once we have it, what do? We go and then we say new words dot append join new alphabets, right? So what is the value of join new alphabets? What will happen if we join all of them? We will have a single string called world. Okay, and now we will put this thing inside the new words, right? Because we are basically saying new words dot append, and we are putting this into the new words list. So what is our next element here? Our next element is world, WORLD. This is our new element. Now how can we get the new string? You know, right? You know it. All you have to do is to join both of them. Join both of them. And once you join both of them, what do you get? What do you get? You get this string. You get hello world. Boom. You have the answer, dude. So you got the answer. You now have the logic how to convert from this ugly thing, this ugly thing in here to here, right? So that is the step here.